Hi friends, welcome to my YouTube channel. Hope you all are doing good. In this video, we are going to discuss about characteristics of water. We will be discussing about physical characteristics, chemical characteristics and biological characteristics. This topic is treated as one of the most important topics for any competitive exams related to civil or related to any water supply or water engineering. First one, we have physical characteristics. Physical characteristics are those which can be seen by our naked eye or can be seen as a particulate matter. So the first physical characteristic of water is turbidity. This is a very important part of this physical characteristics, as definitely one question would be asked in most of the papers. So turbidity is nothing but the characteristics of the water which can be seen by a naked eye. So it is caused by suspended matter such as clay, silt or other finely divided organic or inorganic matter. It is caused due to the presence of bacteria, algae, protozoa, fungi, etc. It is expressed in ppm, that is parts per million, or mg per liter, measured on silica scale. We also have the permissible limit of this turbidity for potable water, that is 5 to 10 ppm. That is, these are the acceptable limits within which it should be present for potable water, measured by turbidity meter. So turbidity is nothing but the suspended matter, that is, whenever you are having a finely divided clay or silt or any other small particles in water which will be obstructing the flow of light through that, this is caused by the turbidity. Okay, so the presence of these particles will just be seen in the water particles. Okay, presence of these matter in water is turbidity. It can be clay, silt or other finely divided materials. It can be inorganic or organic. Remember, it is measured on silica scale. We use turbidity meter for this. Next, we also have types of turbidity meters. Generally we discuss about three types. The first one is Jackson turbidity meter, and whatever the units we measure with this instrument are called as Jackson turbidity units. Use it to measure high turbidity greater than 25 ppm. Whenever the water is having 25 ppm or more of the suspended particulates, we use Jackson turbidity meter. Okay, the turbidity was previously measured by Jackson turbidity units, but now it has been replaced by NTU, that is nephelometric turbidity units. I would be explaining about this in next parts. Coming to the Bailey's turbidity meter, precisely records even low turbidity values, that is 0 to 2 ppm, whereas the Jackson turbidity meter will measure the values of greater than 25 ppm. Here even the small values are noted, that is 0 to 2 ppm. Nephelometer used to record 0 to 1 ppm, that is turbidity is the measure resistance to the passage of light through water. See, I have already told you, whenever the suspended matter or the particulates are more in quantity, more in number in any water, it will just resist the light that is passing through it, and it will not allow the light to pass to the other side. Okay, so the more the material, more will be the obstruction, more will be the resistance, and the less would be the light passing through the water. Okay, so these are the three meters or the instruments used to measure the turbidity. Next, coming to the second most important physical property of water. See, physical element is nothing but something which can be seen by a naked eye. Okay, color, we can see it with our naked eye, right? So color is caused by dissolved organic or inorganic matter. Whenever I am saying dissolved, it is mixed with water totally. But whenever I am saying suspended, in case of turbidity, these are the materials which are not dissolved completely, which are not mixed with water, but they are moving in water like a fine particulate matter. They will not be getting dissolved with that water. Okay, measured by comparing color of water sample with other standard glass tubes. We have Nessla tubes for this. So measured by the platinum cobalt method. Remember this, We have platinum cobalt method, and the permissible limits for this color is 5 to 20 ppm measured by tintometer. See, this platinum cobalt scale is called as tintometer. Using this only we will be measuring the color. See, in case of color, we are not getting directly the units of color or anything. We'll just be comparing it with another liquid. We have some standard glass tube having standard liquid. We will compare this liquid with that standard glass tube. So we'll see the color change using this platinum cobalt scale. Okay? Yes. Next, coming to taste or odor. Taste is something we feel with our taste buds, and odor is distinctive smell we feel. But sometimes it is very difficult to differentiate the water of standard limit and the polluted water, but wherein it may be dangerous to use. So we are having some standard units or standard instruments to measure that. This taste and odor in water is caused due to dissolved inorganic or organic salts, dissolved gases, etc. Threshold number is a standard unit of measurement. Here we are using a standard unit to measure taste and odor. The standard unit is threshold number. For taste it is flavor threshold number, that is FTN. For odor it is TON, that is threshold odor number. Remember, the threshold number is same for taste and odor, but the expression for that is changing. For taste it is flavor threshold number, and for odor it is threshold odor number. We also have some permissible limits of this. It should be within 1 to 3, and there are no units for this, as this is just a number, a constant value. It is measured by an apparatus called osmoscope. We are having a standard instrument for this, osmoscope, and they have some decent developments for this, but this is just the basic questions would be asked. Next, coming to the temperature. Temperature is nothing but the measurement of how hot or cold the water is. Generally 10 degrees of water is desirable, but remember, the water of temperature greater than 26 degrees Celsius is not desirable. Okay, and this is just a general topic. We have like impurities in water, which is very important to know the difference, as I was not explaining this in turbidity or the color parameter. Here I'm explaining the difference between the suspended, colloidal, dissolved, and all that. So first one, we have suspended. They cause turbidity, as I already explained you. The concentration of this suspended impurities is measured by turbidity. Suspended particles are those which will move in water, which we can see with our naked eye. Okay? And colloidal impurities, they are finely divided dispersion of solid particles not visible to naked eye, and they are finely divided, which cannot be seen by our naked eye, but they are visible, they are present at that position. Whenever we are talking about dissolved impurities, they are already dissolved, that is, they are already mixed with water, which are not present in its original state. So we have types in that, and again we have salts, metal, gases. We have classification, that is, we have some salts in water. These are the salts: CaCl2, calcium chloride, magnesium chloride, and all that bicarbonates. Metal, we have gases. Okay, we will discuss about the chemical characteristics and biological characteristics of water in the next video. That is it for this video, guys. If you like the video, please like, share, comment to my channel, and don't forget to subscribe to my channel. I appreciate you watching this video. Thank you.